Hey everybody, welcome to another Fast Tracks Live. My name is Paul Abernathy. Thanks for joining me. Today we're going to be looking at a very simple calculation, yet it causes people to be really concerned that they might see it on an electrical exam. Now, chances are you're not going to see this in the real world because usually in the calculation I'm going to show you today, the engineers do this and you just follow the drawings. But I want you to know that on an exam, you may get a question that asks you about calculating the service, or maybe even just asking you what's the total VA of a school. And so people get confused when they look at the National Electrical Code and they look at the optional method for schools and they want to know when to use it, when they can use it, vice versa, and how to apply it. Because for some people, it looks confusing because it's not how the normal tables look. So we're going to look at that today. And hopefully that'll shed some light on it for you and remind you that our Fast Tracks program, we have Wednesday nights every 2 weeks. So that's included. It's not part of the Fast Tracks program, but it's something that I like to do because people send me email after email, calls. Just had a call this morning where somebody says, Paul, I love how you teach. Now, remember, the Fast Tracks program is designed to give you a lot of material that you have to read it, because the number one thing that people struggle with is reading comprehension. If I can work on reading comprehension with you and have you the ability to read a question, understand it, maybe even read it over and over, you're going to do better in the long run. And then ultimately, if there's any questions that you have, you know that I'm here every 2 weeks. We have a Wednesday night session. We go a couple hours. You bring your questions. That's what the Wednesday nights are for. And from time to time, I will actually do some lessons on those Wednesday nights. So again, it's just extra material for you to learn, right? So let's look into the day's lesson. So what we're going to be looking at is the NEC first. So here's the National Electrical Code. And we'll explain it really quickly before we look at an example and we work it out. So when you're doing a school calculation, as it says here, we're talking about the entire school. We're not talking about portable classroom buildings that are they're not part of the overall school. That's separately. And the reason we don't lump them in is because in this optional method, we're not taking into consideration for lighting, for example, at 125% for continuous loads. We're just lumping values together at their total connected load value, and we're using that to apply some demands. Whereas these portable buildings, they have air conditioning loads that may need to be taken at 125%. They have lighting loads that would be considered continuous loads. So you're typically, for those, you're going to use the standard or Part 3 calculation method under Article 220. What we're looking at is the optional method to do the entire school. That's what we're looking at here. All right, so it says 220.86, it says the calculation of a feeder or service load for schools shall be permitted in accordance with table 220.86, which is the one below, in lieu of Part 3 of this article, where equipped with electric space heating, air conditioning, or both. Okay, why is that important? Well, you can't use this optional method if you don't have heating or air conditioning or both. So I can have heating and no air conditioning. I could have air conditioning and no heating, or I could have both, and then you could use this optional method, all based on diversity. If you did not have heating or cooling or heating or air conditioning at all, then you would not use this optional method. You would use Part 3, the normal general calculating method, and you just go down each element and then add them all up. And that's how you do it when you're using part 3. You'll be able to apply things like the lighting demand factors. You'll be able to apply all of that in 220.45 if you're in the 2023 edition of the NEC. You'll be able to apply all those things, but you're not going to be able to do that with the optional method, okay? All right, so in lieu of part 3, you're allowed to use this demand factors. Now, it says the connected load, okay, the connected load, make sure I'm on the code real quick for you. The connected load to which the demand factors in table 220.86 apply shall include all of the interior and exterior lighting, okay, all the power, all water heating loads, all cooking loads, all other loads, and the larger of the air conditioning load or space heating, okay, for that building, okay? So this is basically a summation, adding everything up. Now, this typically on an exam will be provided for you. It'll be the total connected load. And what you're trying to solve is the calculated load after demands have been applied, okay? Now, it goes on to see the second paragraph here says, feeders and service conductors whose calculated load is determined by this optional calculation shall be permitted to have the neutral load determined by 220.61. It gives you that permission because 220.61 is actually not located in part 4. It's located in part 3. So in order to be able to use the allowances for calculating the neutral, then you have to be given permission to do so, and that's what it's doing here. Now, remember that when we're calculating for the neutral load, the neutral conductors have to be sized to handle the calculated neutral load. There's a process to that over in part 3. We have to take all of those neutral loads into consideration, and we can apply certain values that are given to us in 220.61 for that. That's all this is saying. Now, what most engineers probably do is they'll calculate the size of the ungrounded conductors based on this optional method and just size the grounded neutral conductor the same size. That way they don't have to do any math. That's possibility, okay? But we're going to be talking about the service for an example given today. But I just want to remind you, you got to know how to do part 3 in the general calculation method when sizing a neutral. You need to understand how to do that. It's not all about just doing the optional. You might need to do the general part 3 method in order to come up with your neutral calculated load, okay? All right, so also it says where the building or structure load is calculated by this optional method, feeders within the building or structure shall have ampacity as permitted in part 3 of this article. However, the ampacity of an individual feeder shall not be required to be larger than the ampacity of the entire building. So what that sentence means is that let's say I have my service that I'm calculating now, but typical with the school, you'll have a feeder going out to another panel somewhere in the school. Well, that feeder and the load that's associated with that feeder, you calculate it using the standard part 3 method. Okay, you're just going to come together with all your loads, apply whatever demands can be applied under part 3, and that's the value you're going to use to size that feeder. Okay, so it's important to remember, though, that that feeder, because you're not getting the same demands as you're going to get right here in 220.86, that means that in case that feeder may be larger than the service to the entire building, it never has to be. Now, to be honest with you, for the feeder panels inside of the school, probably never going to be an occasion where that feeder would calculate out to be larger than the service conductor for the entire building, okay? The ampacity that we're getting ready to calculate for an entire building. Chances are that'll never happen. But if you understand how it's written, you just be aware of that. It's just saying that that feeder, individual feeder, will never be larger than what would be acceptable for the whole building. And chances are it never will. But I wanted to make sure you just understand that sentence. And then lastly, this optional method does not apply to portable classroom buildings. Why? Because they typically are not fall into this optional method. They will be calculated under part 3. They'll have air conditioning loads that probably have to be taken into consideration for 40. May have additional motor loads. They will have general lighting that typically is going to be a continuous load, and they're really not taken into consideration under 220.86. Okay. In fact, they could skew the numbers. So you're not allowed to do that. So the easiest way for you to remember that is portable buildings calculate separately, and then ultimately you'll add that value to your overall if they're fed from the main school, for example. But you're not going to add them into the lump. Okay. So just keep that in mind. All right. So let's kind of look and see the table here. This is the table we're going to be working with. So I'm going to expand this view. And you really can't see it under the expanded view, so I'll go on and get rid of the expanded view here. Here's the kind of what you see, the table right here in the middle of the screen, okay? So what we've got to do is we're going to look at a calculation. And what we're trying to do is we need to break it down to whatever the VA is per square foot for this school. We're going to be given a value. We're going to be given the square footage of the school, and we're going to be giving an overall connected load. Now, again, where does all these values come from? Well, again, right here. It says includes all of the interior, exterior lighting, all power, water heating, cooking, and other loads, could be EV loads or whatnot, and the larger of the air conditioning or space heating within the building. So what that's basically saying is, and I'll scroll it down so you can see it from under me. Basically, you're just lumping everything into one big basket, and that's been given to you, and now you have to calculate it out, okay? So that's what we're doing with this example. And this is the optional method, again, to reiterate. All right, so now here's your table. And so the first 3 VA is going to be at 100%. So that means you just take full 3 VA. The next 17 kVA, or next 17, VA is going to be 3 through 20. And then the remainder, that's over 20, okay, is going to be at 25%. So the next 17 is going to be at 75%, and the first 3 is going to be at 100%. Now you're sitting there saying, well, this is probably going to be a lot of VA. What are we doing? This is per square foot. So how do you break that down? That's what we're looking at. How do we get it down so that if I have a certain size school, how do I break it down to a value per square foot so that I can apply these demand factors to it? So let's go look at an example really quickly. All right, so let's look at this example. We've got our calculator, and we can work this out. So we have, what is the load? And we're going to try to calculate what our VA is. It says, what is the load for a 35,000 square foot school supplied by a 208 120 volt with the following loads? Okay, so we've got heating, which is 50,000 VA. We have air conditioning, which is 40,000. We have receptacle loads, just adding them up at 30,000 VA. We have separate loads, whatever they may be. That is 20,000. We have the cooking equipment that was presented to us at 35,000. And then, of course, we have the overall lighting load at 75,000. So these values are given to us. And this is exactly how you could see it on an electrical exam. In the real world, again, it's probably you're not the one to be the one doing this count. The engineer is going to add up all these loads, just take them in one big basket, and they're going to present to you the total connected load. And then they're going to give you the square footage. And they're probably going to already do all that anyway and give you the size and the ampacity of the service anyway. But at the least, you know they're going to have the size, square footage of the building, and you know what everything else associated with it in order for us to be able to calculate it out. So let's look at it. So now if we go back to code really quick, remember what it says, and remind you that it says take the larger of the air conditioning load or space heating load. All right, so if we go back to our example, we can get rid of the AC, okay, because the AC is less than the heat. So we're just going to use the heat. So again, it's taking all these values into consideration. So we're just going to add them all up. We're going to add the 50,000. So I'm going to write that down, 50,000. We're going to take the 30,000 for the receptacles. It's already been added up for us. We're going to take the separate loads, whatever they may be, at 20,000. We'll say that's the other loads that that's what's given to us in 220.86. The cooking equipment, $35,000. And then, of course, the lighting loads, it's $75,000. Okay, so we're going to add all these up, remembering we're not going to include the AC because we get to do the larger. It says it clearly in 220.86, takes the larger of the air conditioning versus the heating loads or space heating loads. So I'm going to do 50,000 plus 30,000 plus 20,000 plus 35,000 plus 75,000. Hopefully you're doing this with me. And that gives me 210,000. Okay, so write that down, 210,000. Now, since we know the overall VA, that is the total, for our calculation, we're using that as our total connected load now. Again, we did not use the AC because we took everything and we took out the AC because it says in 220.86, take the larger heat or AC. Okay, so that's how we got 210,000. Now, how do we find out what it is per square foot? Well, you take that 210,000 and you divide that by the 35,000. So I'm going to divide that by 35,000, which is the square footage, and that gives me a 6 VA per square foot. So 6 VA per square foot, and you can verify this by just taking the 35,000 times 6, and that equals 210. And that was what our total VA was, okay? So that's the first thing. So we had to determine what was our VA per square foot. Now that we know what our VA per square foot is, we can go back to use the table now. So here we're back at the code, and we'll go back to this table. Okay, so we have 6. So we're gonna be using 0 to 3 and then 3 to 20. Here's what we'll be using. Okay, so the first 3 VA of that 6 is 100%, right? So that means we're going to use 3. Write 3 down. That's 100%. The first 3 VA per square foot is 100%. So that's 3 VA. The over 3 through 20 is where our next 3 falls in, okay? Because you take the 6, you take a 3 away from it, you got 3. That's the amount that's over 3, and it's 3. So what do? We apply 75% to that amount, okay? So we take 3 times 0.75, and that equals 2.25. So we write that down. So now we simply add the 2 together. As it says right here, you go add the plus 3, means we're going to put that original 3 back at it. So now we've got 2.25 plus the 3, and that gives me what? That gives me 5.25. Okay, that is our calculated VA per square foot. It's 5.25. Now, how do we get it back to VA for the entire building to do our calculation? It's pretty simple. All you do is take that 5.25, multiply it by what? The 35,000 square feet of the building. So I'll take you back here, 35,000 square foot. So I take that 5.25, multiply it by 35,000. And that gives me 183,750 VA. That's the value now that I'm going to use to continue out my calculation. Now, in this case, it's a 3-phase 208-120. So the square root of 3 is 1.732, right? So we take the 208 times 1.732. That gives us, hold on here, 208 times 1.732. That gives me 360.256. So 360.256. It's not going to change whether you just want to use 360. If you want to round it to 360.26, it's not going to make a difference. We'll use the exact value, 360.256. So what are we doing? All right, we're going to take that 183,750 VA that was our now calculated VA. So that's 183,750. And we're going to divide that by 360.256. And that is 510 amps. So the size of this is 510 amps. We go to 240.6a. Overcurrent device doesn't correlate, so we're going to go up to a 600 amp overcurrent device. All right, we can double check that. Let's go check We always got the code that allows us to check that. So let's go back to the code and just double check. Maybe I'm missing something. So we're going to go to 240.86 and see what we got, standard size. Maybe I am missing it. So we got 500, and ours was 510. So there you go. We go to 600, and that's the size. All right. So our conductors are going to be sized to handle 510 amps of load, right? And again, as long as we're not exceeding 510 amps, we size that conductor. But the overcurrent, we are permitted in 240.4b to do what? Go to the next standard size. So we're going to go up to a 600 amp overcurrent device. And as long as our conductors are sized based on the calculated load, we're okay. Everything's hunky-dory. And that's how you calculate it out. So a lot of people are confused with how to do the school's optional method. It's just that simple. Take your total square footage, take the total connected load they give you, do the math and get it down to the VA per square foot, okay? Once you do that, then you can use the table. Once you find out what the calculated VA per square foot is, then you multiply that by the square footage. That will bring you back up to your total VA. And then you simply divide that by whatever the voltage source is for your building. And that's how you're going to get the amps. And then you size your conductors and overcurrent protection device accordingly. All right. All right, folks. Hopefully that wasn't too overly complicated for you. We appreciate you following us. And remember, if you really want to learn the National Electrical Code in really good detail and you want to have access to our Wednesday night sessions that we do every 2 weeks, do me a favor right there. Go to this website, jot it down, share it with a friend. We'd love to have you in our program. Even if you're not preparing for an electrical exam, it is great to get engulfed into the NEC. It'll make you a better electrician. It'll make you a leader. You'll be somebody that can stop going on social media and posting false information. You will actually learn the NEC, and that's what I'm all about. All right, folks. Hopefully you enjoyed it. Until next time, stay safe. God bless.